Yeah, I was a very strange child. I would sit in the basement, no sound, silence, and I'd just sit there and rock. And I'd do this for hours and hours and hours. I think my parents thought I was insane, but what I was doing is imagining futures, imagining what life could be.
The next step in human evolution may not be biological, but technological. By merging ourselves with machines that augment and enhance our physical and perceived realities. But this is no small feat. I mean, the human form is a product of billions of years of natural selection. And that's why innovators like Hugh Herr are actually looking to nature for inspiration to bridge the gap between man and machine.
When I was 17 with my climbing partner Jeff Batzer, we ice climbed Huntington's Ravine on Mount Washington. We got disoriented in a complete blizzard and spent the next several days trying to get ourselves out to civilization. We made it within a few miles of a roadway and we couldn't walk. Our lower limbs were completely frostbitten, completely numb. Luckily, someone was out snowshoeing, saw human tracks, and we were plucked from the mountain via helicopter. Then I spent, months in the hospital. Gangrene had set in, was slowly making its way up my body, and it was clear that amputation was necessary. About 12 months after my limbs were amputated, I was climbing at the same level as I had before the accident, and people started to get nervous. And then I exceeded that level and started to climb walls that no one ever climbed before. And then I became a threat, and that happened overnight. Some of my climbing colleagues actually threatened to cut their own legs off to achieve the same unfair advantage as me. No one actually did it. The fact that I could design my body part and exceed what I had achieved before and even exceed what nature intended was very inspiring, because I realized that technology has the power to heal, to rehabilitate, and to even extend human experience and human capability. That set me on this trajectory of tinkering, of designing, of climbing, and then going back to the shop and whittling and carving and machining. I mean, my closet looked really funny. You didn't see shoes, you saw all these bizarre limbs and feet everywhere.
So what sets Hugh's legs apart from the rest? Most prosthetic legs are passive, and as a result, amputees have to use about 20% more energy when walking with their prosthetic leg. Hugh and his team studied how our leg and ankle naturally work to create their bionic counterparts.
So our key strategy in the design of bionic appendages is to look into nature. So we studied how the calf muscle works, for example, and how the calf muscle is controlled by the spinal cord using neural reflexes. And we programmed that capability on the small computers that are underneath the shell in the bionic limb, so that when I walk at different speeds and different terrains, it's constantly updating the stiffness and power it's providing me.
The motor mimics our calf muscles, adding positive force to the prosthesis, and that propels the body forward. This is especially helpful for walking up ramps and stairs.
So that even though the limb is made of titanium and carbon and all these synthetic materials, it moves as if it's made of flesh and bone. The value of closely respecting the biophysics is that when we fit this prosthesis to a human body, there's often no training, because the human body remembers how to walk.
Oh my God, I can't believe it! It's just like I've got a real leg.
That's the value of this biomimetic design approach. We built our first foot ankle in 2002, so it's been a long iterative process. Probably 30 fundamentally different designs that led to the bionic limb as it exists today. We're studying how the tissues in this part of my body, how stiff they are. We're studying how the skin moves. And we then 3D print structures that emulate those tissue properties.
It looks like a topographical map of your residual limb, and it makes for one of the most comfortable sockets available today. Besides the physical attachment to the prosthesis, Hugh's team is working on a way to control bionic limbs more naturally. They've developed legs with EMG sensors that measure and decode the electrical impulses in the muscles of the residual limb and then translate that into movement. Thus, the user only has to think about moving their leg to activate the bionic limb.
I have the condition that my limbs are amputated. But that condition, because of great technology, I have the quality of life that I seek. Extending that story across all of humanity, one can imagine a world in which technology is so remarkably great that we can eliminate disability. And I believe that will happen in this century. The twilight years of this century, there will be no disability in the world.
Check out more episodes of Cyborg Nation by subscribing to the Wired channel.